we're looking at this idea of iteration. That's kind of a funny word, iteration. It's not irritation, it's iteration. If someone says, hey, could you reiterate that? What does that mean? Anybody know? Mason, would you know what that means? Well, no, the question is, hey, if someone asks, could you reiterate that? What does that mean? Yeah, do it again. That means do it multiple times. So iteration is this concept of doing the same thing over and over again. Another word for that that computer scientists use is a loop. You just do something over and over again. Now, at some point, you have to stop doing it over and over again, or otherwise your computer is in an infinite loop. And typically, infinite loops are bad for computers. That's another way, we were talking about earlier about if you want to blow up a computer's brain, just give it in an infinite loop to chew on, and pretty much everything crawls to a stop. But let's take a look at the while loop and the for loop. Now, there's a video out there I was hoping that you get to before, and you should have had time to read section 6.1. That's pages 193 to 201 in our book. This video goes over that, so I'm not going to go into detail over the while loop, but I do want to compare while loops with for loops. Okay, there's different kinds of loops. Two of the most common are while loops and for loops. So our guiding questions today are, what are for loops and how are they similar or dissimilar to while loops? And then there's a question like, when do you use a for loop instead of a while loop? They're very, very similar, but there's only a few little things that would make you use one instead of the other. And then this concept of a nested loop, we're probably not going to get to that question today, but let's start with just comparing for loops and while loops. Well, before we start that, I want to just show you what we're talking about, okay? What is a loop? Well, when you're trying to, oh, and Garrett and Mason, I did fix your attendance yesterday. Yeah. Can you see that in student view? Yeah, you can. Yeah, and Garrett, I updated yours as well. Okay. Is Garrett here? Yeah, they're right there. Okay, cool. Yeah, sorry about that. I like to use something called a flowchart when I'm talking about loops. Flowcharts are really good for showing how logic flows through a computer program, and there's specific symbols you use when you're doing a flowchart. But let's say we have this variable I, and we set it equal to 0. Okay, I is considered our I is what we call a control variable. Why do they call it a control variable? It's because it controls how many times you execute this loop. That's what a control variable is called, or is used for. So we come in the top of this loop, let's say, we initialize our control variable to 0. So the first step you do in any loop is you initialize the control variable. In our example then, our control variable is I, so we initialize the variable I to 0. I'm gonna stop sharing my screen so you can see my screen really big. Although I'm not sure where the controls are now. Oh, there it is. So I'm stopping my sharing right now. I want you to be able to see this. Is it nice on your screen now? Hope. All right. That's the first step in any loop, is you initialize a control variable. Now, while loops and for loops are very similar in that they're both top-driven. Well, what does that mean, top-driven? Well, that's the next thing you have to do, is you have to test the control variable. That's the next thing you have to do. Now, when you do a test, like if you're asking a question in flowchart language, what you use for the symbol for that is a diamond. So here's our flow. We go into a diamond shape. And we're asking the question if, let's say if I is less than 5. Say we want to do this 5 times. So the first time I will be 0, second time I will be 1, third time I will be 2, fourth time I will be 3, fifth time I will be 4. But once I becomes 5, if I equals 5, well, 5 isn't less than 5, and it will stop the loop, okay? So the true part, when you do this test, this is a question, right? Put a question mark. You ask this question, is I less than 5? If that's the case, if that's true, here's our true part. You say true. You can label it. If that's true, well, then we want to do something. It'd be silly to have a loop that doesn't do anything. So you have a block of code here, and that's just a rectangle. Do stuff. How's that for fancy computer talk? You do stuff. I mean, it would make sense. It would make sense to have a loop where you didn't do anything in the middle of the loop. It's got to do something, okay? Or there wouldn't be a need to have a loop in the first place. But then after you do the stuff you need to do over and over, you know, this is the stuff we do multiple times. Here we just do it once per loop, but it could be done multiple times. And we get to the bottom, and the flow of control goes back up to the again, or the question, right? But there's a problem here. Anybody see where the problem is? We did some stuff. So we say, well, I equals 0. Is I less than 5? Yeah, it is. So we do stuff. Then we go back up the top. I is still 0. Is I less than 5? Yeah. And so we do more stuff. Yeah, question. Yeah, so you've got to be explicit. If you don't change the control variable, right? Here we test it, but there's this third thing. Change the control variable. If your loop is missing any of those 3 pieces, it's not going to work right. Whether it's the for loop or the while loop. So here at the bottom then, hopefully you can see that. Yeah. You might say I equals I plus 1. And then go back up to the top. Okay. See how that works? That's why I like these flowcharts, because you can see the picture and you can see how the logic flows through the system. So we change the control variable. We're going to do this 5 times. Now, in programming land, programmers hate starting counting with 1. If you ask a programmer to count, they'll say 0, 1, 2, 3, 4. They won't say 1, 2, 3, 4, 5. It makes algorithms simpler to understand if you just start counting at 0. Most normal humans start counting at 1, but programmers always start counting at 0. Okay. So this gets done 5 times, even though it says less than 5 and not less than or equal to 5. If we said less than or equal to 5, we do it 6 times because we started at 0. Beginning programmers typically would set the control variable to 1 and then say less than or equal to 5. But that messes up other algorithms that were easier to understand if you just start counting at 0. Way back in history, in mathematics, there wasn't a concept of 0. There was a concept of 1. There was a concept of -1. But there was no 0. And it messed up all the ancient mathematicians struggled with this fact that they didn't have a way to represent nothing. It didn't make sense to them. Why do we need a symbol for nothing? finally, the Persian mathematician said, oh, it would be great if we could have a symbol for nothingness. And so they came up with this concept of zero. And then math became a lot easier to understand. So it's not just computer programming, it's also in mathematics. It's like, in the year 2000, I go, probably, was anyone here born on or before the year 2000? I don't think so, other than me. But what people are saying, hey, let's celebrate, when it was New Year's year 2000, everybody's celebrating the new millennium. They say, hey, it's the start of a new millennium. And I go, no, it's not. What do you mean? It's the year 2000. It goes from 1999 to 2000. Let's party. And you go, well, technically that's not right. And I go, what are you talking about? Well, there's no year zero. Yeah, is that right? Right. So the new millennium doesn't really start till 2001 because there's no zero. You go from 1 BCE. The next year is 1 AD, right? There's no zero. So if you go 1,000 from 1, that's 1,001. If you go 1,000 from that, it's 2001. So the new millennium doesn't start till 2001. So I point this out to people saying, really, it's not the start of the new millennium. That's not until next year. And they would tell me to shut up. So let's party like it's like, 2001. It's like that Prince song, right? So yeah. So what I did, and this is kind of funny, at my dad's place, we were all at my dad's place up in the mountains. I'm going there this weekend. Yeah, it's true. Yeah, technically, but nobody cares about that, it seems. But I'm going to my dad's place. But it was 2000, the year 2000. I was downstairs in my basement when they were counting down because it's the new millennium, or kind of. And I'm at the fuse box. There was this Y2K problem where the whole world was supposed to fall apart once the date changed over the year 2000. So I was going to shut all the power off. So I did right when New Year's happened. I shut all the power off, and everybody goes, "Oh my gosh, it's the Y2K! It's the end of the world!" It was funny. My wife did not appreciate that, though. She was very angry with me. Why is that? Why would your wife be mad at you? You're supposed to be with your wife, giving her a smooch when it's New Year's, especially that one, because that only happens once every 1,000 years or so. So I still get some grief because of that. So. But anyway, start counting at zero. It makes life so much easier when you're doing loops, okay? Well, have I specified that this is a while loop or a for loop? And the answer is no, because they're the same, pretty much, okay? They have the exact same structure. For loops, while loops, they're both top-driven loops. They do things multiple times. You're good, okay? But what makes you use one over the other? Well, I guess the big one that I always point out, and I'll think about this some more because it's kind of a philosophical question. But if you know exactly how many times you're going to do the loop when you write the code, you know how many times. I want to do this 5 times. Then use a for loop, okay? That's what for loops are for, is if you know how many times you're going to do it. If you don't, at the time you write the code, you don't know how many times it's going to loop. Say it's based on a user input. Let's say, how many times do you want to do this loop? You ask the user, and the user says 27. And so you can't know that when you write the code. If it's unknowable how many times you have to do it, don't use a for loop. Use a while loop. Do it while this thing is true, and then finally. So if it's all dependent upon, at the time you write the code, do you know how many times you're going to do this loop? If you know that, then use a for loop. If you don't know that, or you can't determine that until runtime, use a while loop. Okay, that's the difference. And we're going to go over in detail why that is. Okay. Okay, how much time we have? We still have a lot of time. Okay, so we're gonna take a look at. I'm assuming you watched the video on while loops, so you kind of have an understanding there. And this is pertinent to that. But now what we're going to do is look at the syntax for a for loop. Okay. In a for loop, let's compare while loops and for loops. Okay. In a while loop, the code might look something like this. Int I equals 0. So you initialize your control variable, and then you say while I is less than 5, and then in curly braces, you might say system.out.print print line, lowercase, and you print out the value of I. You add 1 to I, and then you close out the loop. Okay, so this loop will count to from 0 to 4, and we'll print out the value of I each time it goes through the loop. Here's the initialization of the control variable. Here's the test. Here's the change. Now I++, the plus operator just takes whatever variable you have and adds 1 to it. It's called the increment operator. So I'm changing the value of the control variable, so this is not an infinite loop. If I didn't have that line, that would be an infinite loop, and this program would forever, until the end of time, be printing out the value 0. Okay? You have to have that change of the control variable, or it goes forever. Most of the time, you don't want an infinite loop. Sometimes you do, but in general, they're evil, and then will destroy your program and your operating system and life as we know it. If you actually code one of these, you get sucked in a black hole and you die. So just don't do it. It's not good for your computer. Now I'm exaggerating a tad, but yeah, you don't typically want an infinite loop. Sometimes you do. Like if you have a game loop that constantly loops, checking to see what the user is pressing, well, that's an infinite loop. Or your microwave is in an infinite loop waiting for you to press a button. So there are times when you use infinite loops, but generally, infinite loops are bad. You get to a certain part of the code, your code starts looping, your mouse stops talking to you, keyboard doesn't work anymore, and the program's still on the screen, but you can't do anything. You experience this same situation over and over as you use computers, right? You have a program that's just unresponsive. Why doesn't it respond anymore? Because it's stuck in an infinite loop. But programmers, especially C programmers, really dislike while loops because there's all this typing. There's too much stuff. We want to condense it down. We want to be more concise. Okay. And so there was this urge to say, well, why don't we do the 3 things that we need to do? Initialize the control variable, test the control variable, and change the control variable. Why can't we just do all of that in one line instead of, well, how many different lines? We got, there's the initialization, there's the test, there's the change. Okay. That's 3 different lines. Too much typing. C programmers would say. They like everything short. And you use loops all the time. So they get tired of this. You only do this when you have to, when you don't know how many times it's going to go. You use a while loop. So how would you write this as a for loop? It's the exact same loop. It does exactly the same thing. How would you write that? It's so nice to have a board. Did I mention that? How exciting I am, excited about having a whiteboard to draw on. You know, I didn't have that at home. I can actually write on the board. It's so exciting. You're a teacher stuck at your house. I've been stuck in my house too long, so this is really cool. All right, so how would you write this? So here's our while loop in Java. Well, let me get a better pen. That's our while loop. But what does the for loop look like? Well, you say for. Well, actually, there's no capital. I want to do this right. So separate this. So I say for int I equals 0, and then a semicolon. Is it a semicolon? Yeah, it is. You say for int I equals 0. So there's the initialization of the control variable. And then you say I less than 5. So there's your test. And then you say I++, because that's nice and terse. And so you have all 3 parts of every loop in one line of code. you have the initialization. This happens only once. This happens at the top of each loop. This happens at the end of the loop. There's the initialization of the control variable. There's the test. There's the change. These three things: initialize, test, and change. So now all you have to do, since you've done all those parts, is you say, well, I'm going to just do my stuff. What's my stuff? System.out.println. Hi. I'm just counting, let's say. Ooh, this is cool, because now I only have, in essence, 2 lines of code, where this thing has 1, 2, 3, 4 lines of code, if you don't count the little curly braces, okay? So programmers, especially C programmers, prefer this syntax over that. That's a mess. Too much typing, too much indentation. Here it's very hard to understand, right, if you're not a more advanced programmer, but it's a lot less typing. And since we do this all the time as programmers, people much prefer, programmers tend to prefer for loops over while loops. But they're functionally the same. They're functionally equivalent. If you know how many times you're going to do the loop, then use a for loop. If you don't, let's say I is not equal to 0. Well, let's say, yeah, I starts at 0, but instead of 5, you say, I don't know, based on some kind of user input, user response. So in your program, you ask the user how many times they want to loop. How many? Say this is. Say it goes backwards. Say instead of, if you're doing like a rocket launch, you're going to go 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? So, but say in some countries, they don't want to start at 10. They want to start at 15 or 20. It's all depends on what the user says. Well, you can't know that when you code the program. Since you can't know that, then you would use a while loop. But if you know it's always going to be 10, then you would use a for loop. Okay? You can hard code that in there. But again, it's what you know at the time you code it. That's what it's important. Loops are really, really cool. But by themselves, they're really not that helpful. But when you talk about this data structure called an array, then loops are the coolest thing on the planet, because you can do this. You can do a loop through like 10,000 things in microseconds, right? So we haven't really learned the power of loops yet, but we've learned at least the structure. And hopefully, as we go through the chapter some more, we'll learn the power. And the power is incredible. There's so many cool things you can do with loops. But you have to pair them up with arrays. Arrays is a data structure. And you could have tens of thousands, millions of the same kind of thing, just data. And you can crunch through it all with just a tight loop like that. And you can do amazing things on a computer if you can do that. So anyway, that's loops.